Hello, everybody. Good afternoon, and thank you for the opportunity. I'm Hui Li from School of Mathematics at the University of Birmingham. This is a joint project with Yuyue Liao, myself, Lin Ling, and Zhen Xinge from the Central University of Finance and Economics in China. So we are going to investigate performances of online crowdfunding user application of hybrid tree regression models. So the structure of the talk is laid out as following. We start with motivation, and we talk about methodology, a few models, what motivate this and how it goes. And then we introduce that to the crowdfunding data. Then we'll conclude and talk about the future work. So the project started with discussions which I had with Yue about the challenges of improving predictions in meta-analysis. In meta-analysis, an extensive range of categorical variables are frequently employed to measure specific attributes. Similarly, during a conversation with Professor Zhen Xinge at Central University of Finance and Economics in China, her team also expressed interest in improving the prediction of crowdfunding success. But there, in their data, where the dummy variables significantly dominate the data. So this shared interest sparked our collaboration on this topic. So in statistics, we understand that decision trees can be employed to identify interaction effects and handle outliers. Meanwhile, we often rely on the classic regression methods to generate continuous predictions. So our thought really is that what if we could combine the strengths of these two methods? Could we optimize prediction accuracy in that way? And how can we implement this research? So, so in the following talk, we're going to explore this topic a little further. So, classification trees are used in classification analysis, of course, and being able to deal with cases where categories are not linearly separable. Well, regression trees is being able to detect interaction terms and outliers. So the CARD algorithm, which was first published by Leo Bremen in 1984, is widely used and as powerful decision support tool for the tree analysis. So the regression equations we treat as equivalent to regression trees, where we use leaf nodes to create new variables, and also we can use splitting points to create new variables. So in the classical regression, we have all the variables over there, but in the tree regression, we treat the variable at the nodes and the variable at the split points as our new variables. In the literature, there are quite a few studies explore the hybrid tree regression methods. We list a few significant improvements. So in 1998, Steinberg et al. They designed a hybrid classification algorithm based on decision tree and logistic regression. The algorithm applied leaf nodes of decision tree as additional independent variables in the logistic model. According to the real-world data and Monte Carlo simulations, hybrid models performed better than both logistic regression and regression trees. So after that, quite a few, a lot of researchers actually explored this area. So we highlighted Kim et al. In 2017. They applied 10 mixed data sets. They concluded that the hybrid tree linear methods outperform linear regression models, including an OAS, ridge lasso, and regression, and support vector regressions. So they find that the hybrid methods provide smaller mean square errors, MSEs, in cross-validation. So later, Dumitrescu et al., their group in 2018, they applied decision tree to detect discontinuity in the relationship between the dependent variable and continuous regressors in logistic regression. They proposed a penalized logic tree regression. They found out these penalized logic tree regression outperform both linear and quadratic logistic regression models with prediction accuracy slightly lower than random forest. However, it has the advantage of being much more expandable. So we would say that up to our knowledge, they made the first attempt to incorporate the results of multi-decision trees into one regression model. So the standard linear regression model, certainly we are very familiar with. So here the beta is intercept term, and all the z variables are categorical independent variables associated with the parameters deltas. And x are continuous independent variables with parameters betas, and epsilon here is the random error term. So now applying similar idea to the hybrid model, so certainly the idea, the first one proposed that is Sandberg in 1998, but we applied the idea that Kim and their group in 2017, they use splitting points instead of leaf nodes to create new variables. So using their way, so we can build our hybrid tree linear regression model in our analysis. So we start with the so we start building regression tree with dependent variables and all categorical independent variables. So we create new category variables based on regression tree, but instead of the variables that refer to leaf nodes of decision tree, so we applied here the variables that are associated to splitting points in decision trees as new independent variables in the regression model. Although the two ways of generating new variables are mathematically equivalent, variables generated by splitting points are products of fewer original variables, so therefore they're easy to interpret. So the algorithms that we use in the hybrid tree linear regression model very similar to what Kim did in 2017. So it's presented here in slides 8. So we build the regression tree model first between the response variable y and categorical independent variables. Then we'll create a new categorical variables for each splitting point. Then we run regression model between y and all the independent variables, as well as the categorical variables we created from step 2. Then we apply stepwise regression to select the variables included in the regression model. So typically, this algorithm can be written as the equation 2, which we call it HTLR. The T stands for the hybrid tree linear regression model. And here, the Z here refers to the set of nonlinear variables. So Fz is nonlinear function in this model. So now, so in the so for example, in the crowdfunding data we have, so this is the tree we created by using HTLR. So here, the decision trees built here is shown in figure 1 here. So the supporting whether the receiver support other projects is our root here. So if they don't support it, it's go to 0, which go to the left-hand side of the tree. So if they do, they go to the right-hand side of the tree. So then the new variable we created is all at splitting points. So instead of at the root. Now for this case, if we use leaf nodes, so we can create the variables created will be 1 minus the SPT, which is the first node here, then we certainly will get to 1 minus whether reward is a product or not. Okay, it's a splitting point, and 1 minus the compact. There's another splitting point over there. So of course we can go all the way down to make all the interaction terms. However, if we using a splitting point, so we can splitting is just 1, 2, 3 for 3 interactions here instead of go to for 1 variable, and then we go to the other one. So will be support times the reward of product, compact times the reward of the reward for LET, whether okay, LET. So the variables, we have 6 types of rewards in the data. So rewards LET, whether the sponsors of the project receive letters or thank you letters or not. So this is another one. We can create another variable by using the splitting points. So this, if we use splitting points to create category variables, they because it's shorter root, so it's more likely to provide it clearer meaning. Now, the hybrid tree regression, linear regression methods only allows us to find a result of 1 decision tree to be added, which means that all the interaction terms included in the model are related to each other by sharing the same root node. However, in the real-world data, there is often a wide range of nonlinear relationships. So these which do not frequently share a common variable, common root. So to allow multiple interaction terms that do not share a common root variable to enter the tree-based regression model, so we are thinking about to include the results of multiple decision trees. So to build multiple decision trees, so we certainly start with the linear regression model. Then we run the regression model using category variables in the active set and remove the root node from active set. Then based on decision tree, we add new categorical variables to the regression model. So from there, so we'll decide, is the new regression model better than the previous one? So if yes, then we run the decision trees again to start a loop. So add new decision trees until the condition is satisfied. So if the new regression model is not better than previous one, then we select the best model in the loop process and as our final results. So to make this, we certainly this is the algorithm we follow for the hybrid forest linear regression model. So the algorithm over there is provide to explain the loop that which will enable us to build more trees, and which is expansion of the hybrid tree regression model. So the model that for the hybrid forest linear regression will share the same one as the hybrid tree model. So I didn't rewrite it here. Now, so if we can briefly summarize, so far, if we talked about try to model the relationship with a set of continuous regressors and a set of categorical regressors, so which we denote as Z and X for the continuous regressors. So we'll try to find a relationship between X and Z, how they influence the response variable, which is Y. So we could use a linear regression model. So we assume FZ is linear, but the tree model. So in the tree model, we can see that FZ's function can be written as a root node of decision tree, and so which is Z0 here, or we can also add in the other regressors, which consider as a splitting point as a new categorical variable. Now we can push it further as a hybrid forest linear regression model for the function FZ, which can take both linear and nonlinear forms. So we generate 12 12 simulated prediction problems to evaluate the performance of linear regression model and hybrid tree linear regression model, hybrid forest linear regression model before we apply the data. So these 12 simulated problems are typically based on the setting of the Yij equal Yi0 plus epsilon j, where I equal certainly 1, 2, 3, 4 layers, and j is 3 layers. So here we would assume that we would generate Y0 as an IID variables, and X, we assume that they are uniform distributed. And so here is Yi0 should have X over there, a uniform distributed random variable with 0 to 10. And these we will the dummy variables in the model, and they certainly, for dummy variables, the probability followed by Bernoulli distribution. So and we choose J will be 1, 2, 1, 3, 5, 7, 9 out of choices. Probability will be I divided by 10. So for the simulation, we run this for 300 runs. So we can see that Y10 is straightforward linear regression model. So Y20, this is a linear regression model we introduce that with nonlinear terms with all the dummy variables. And so once Y30 and Y40, certainly we just expand the linear term and the nonlinear terms, which comes from the dummy variables. So all these coefficients, we introduce that in order to reduce the noise, so that's easy for us to do the comparison. So to do the comparison, we certainly compare the standardized mean square errors in the both training set and the test set. So in the training set, we use 300 sample size, and the test set we use the 100. So let's take a look at the training set. The last page is a test set, right? So the highlighted portion are the ones that are based on the linear model. So in both the training and the test set, we can see that the linear regression has its advantages, also performs better if the variables are linear. So while when we consider more nonlinear terms, the hybrid tree model, the hybrid forest model stands out. Especially the hybrid forest model, which is the last column over there, have more significant results or smallest standardized MSE when the model get into have more nonlinear terms, when we consider more nonlinear terms in the function. So from the Monte Carlo simulation, and so we found out for the both training and test sets, the performance of methods varies depending on the circumstances. For the linear regression model, the average of the standardized cross-validation means of error is 2.203, which performed better when only linear relationships existed. So which we consider the highlighted the first 3 models in the test set and the training set. For the hybrid tree regression model, the average of the standardized cross-validation MSE is 1.525. Perform better when either only linear relationship existed, or all nonlinear relationships share a common variable. So, on the other hand, the hybrid forest linear regression model, we found out have the smaller, which is 1.4, the average SCV MSE, perform better when when all the nonlinear relationships existed. So the forest model, the hybrid forest linear regression model, was more robust than the linear regression and hybrid tree model when the nonlinear relationships are more complex. So we also take a look at the ANOVA analysis, which will help us to access the effects of various parameters on standardized MSE more accurately. We applied a three-way ANOVA to the simulated data. So we consider three models, which is linear regression, hybrid tree, and hybrid forest. So we consider number of trees that the hybrid forest model generates, and also we consider the standard errors. So here, M stands for the methods we're going to compare and analyze, which is LR, HTLR, and HFLR for these linear model and hybrid models. And T stands for the true number of trees. So we start from 0, no trees, and 1, 2, or 3, which were the algorithm from the hybrid forest model will tell us. Now, standard deviation error terms, we also set into different levels to capture noise of the model. So we set it to 2, 4, and 6. So here, as we can see that the interaction effects between the true number of trees and standard deviation, certainly it is not significant. The p-value is 0.1875. The other two interaction effects across the first one, the method across the true trees is mildly significant at 10% level. The methods, the interaction effects between the methods and the standard errors is significant at a 5% level. So we can certainly take a further look and take further look at the interaction plot between the methods and the number of trees over there. So we can see that the blue line, the light blue line shows the performance of the hybrid forest model, and the green line shows a hybrid tree linear regression model. So these certainly we can tell they have interaction effects over there. So while the linear regression model increases have much larger noise over there. So what we can tell here, though, is that a hybrid forest linear regression model was more robust than the other two methods, and as the trees and standard errors changes, and tree-based models were superior to linear regression models, regardless of the standard errors. So far, the simulation gave us a good understanding or introduction to the performance of the three methods. So we are ready to see how these methods perform in the real-world data. So the one we're trying to analyze here is crowdfunding data. So the data was collected from two leading global crowdfunding platforms. So one is Kickstarter, the other is Indiegogo. The data collected is from 2016 to 2018. On the left-hand side, the screen is Kickstarter, which is have a green highlight over there. So and the right-hand side is Indiegogo. So these two platforms, there's two major ones so far for the crowd fundraising. But these two, although these two both charge the same flat fee, which is 5% platform fee, plus payment fees. So from the fee paying per se, they're quite standard. However, if we break into details, these two websites operates differently. And the Kickstarter, according to similar web to monitor traffic, they reported that there are 19.5 million unique visitors amongst visit Kickstarter. So, and also, as of the March 2023, it is reported that top 3 funding categories from Kickstarter will be games, takes $2.1 billion, followed by design and technology. So Kickstarter also boasted that they have a successful rate of funding the projects of 39%. But a close look will see that there is 10% of the projects, although it's get funded, which count as success, which has been for a long time inactive. So the successful rate is about 30%. The Indiegogo started to fund independent films. So we can tell from indie, so independent the films in the beginning. So Indiegogo, according to SimilarWeb, they report an average of roughly 5.6 million unique visitors a month, which is less than a third of Kickstarter. So there are three primary categories. Indiegogo also quite different from the Kickstarter. The technology and innovation is a top category, followed by creative works. Then the third one is community projects. So the successful rate, according to the website, it's hard to find the stats about this, but we sourced from other research from other reports. It's similar, about 9%. The 9% seems to be low. However, the Indiegogo, though, they have a flexible funding model, so which means that even the project is not fully funded, the proposer will also receive the whatever the percentage of the funding they collected. So on the other hand, Kickstarter will be either fully supported or no. Okay, fully successful project get funded, or no, they cannot take it. So Indiegogo also have its unique flexible model, which attracts proposers. So the projects, so our project starting searching the keywords social enterprise or social entrepreneurship in the search for the project for the from 2016 to 2018. So after collecting the initial data, we certainly cleaned up the original data by removing the projects with extreme values variables, such as the funding ratio, funding targets, number of followers. So after that, we netted 236 social entrepreneurship projects, of which 52 from Kickstarter and 184 from Indiegogo. So certainly, we have an impression that Kickstarter have much more unique visitors compared to Indiegogo. However, because we're interested in this type of project, which is social enterprise, that is one of the key categories in Indiegogo. So we get more data from Indiegogo. This is also captured in our model by indicating the source of the data. So among the 236 projects, the majority came from the United States and United Kingdom. So 44 from the UK and 84 from US. The rest from the just globally, internationally, from the rest of the world. Among these, a total of 126 projects were initiated by females, while 95 projects were initiated by males. The remaining projects were listed as being initiated by organizations or groups. So here, let's take a closer look at the data and examine it in more detail. So the dependent variable that we're going to analyze in this study is proportion of financing, which is a ratio of the size of financing and the fundraising target. So among 236 projects, 52 completely being funded, which takes about 22%. So for the unsuccessful projects, 73 projects were partially funded, which takes about 31%. That is between 10 to 100% between these percentages. We also got 56 projects, which takes about 24% as the 1 to 10% funded project. And we also have 52 projects with 23%. It's quite poorly funded, with less than 1%. So this is our response variable we're going to analyze. So in the model, we also consider two continuous independent variables, only two. So the first one is fundraising target, which varies from $120 to $631,000, with an average of $35,689. We're also interested in the number for the displayed pictures on the website for the project. So that ranges from 0 to 66. On average, 6.5 pictures were posted on the in the project on the website. The majorities are binary, we say dummy variables. So I just listed the key ones here. So each variable has special have its own names. So I listed here without the list of variable names, so that we can easily appreciate the feature of the data set. So which website, which Kickstarter or Indiegogo, certainly we use dummy variable to indicate that the source. So the topics project, we have 3 dummy variables. So community activities, which takes 42% of the data. So whether the project involved actual producing product or not, it is one variable. Whether the personal information of the founders or the proposers, the founders, has been revealed on the website, we create 8 variables. For example, whether the pictures was over there or whether they supported other projects over there. So we create 8 variables over there. So we also created 10 variables to indicate rewards for sponsors. For example, we indicate whether the rewards will be products, which takes 71%. So some projects, they wouldn't reward products, they would issue honor certificates. So for example, 44% of projects offer certificate. Some projects also offer thank you letters. So writing thank you letters to sponsors is about 42% of projects. Now, about the pictures displayed on the website, we also create 5 variables. So the pictures of the providers, the pictures of receivers who receive these the funding, and the pictures of the products, the pictures, the production procedure or the environment. For example, they have a attitude over there. They can produce for the manufacturing process. So these will be the environmental production. If the website posts slogans, logos, missions, and plans over there, so we also capture that by using dummy variable, which is about 52% of projects posted slogans, logos, missions, or plans. So let's first focus on the model comparisons before we moved on to the modeling results on individual variables. So we applied the 3 methods: a linear regression, hybrid tree model, and hybrid forest linear regression model to the crowdfunding data. So we found out that the hybrid forest model, which is last column, have 3 stars over there, have higher explanation power and prediction accuracy than linear regression model and the hybrid tree models. So we can see that if we compare as a Bayes information criterion, the hybrid forest model has a smallest number with 370. So if we take a look at cross-validated mean squares of errors, so we also see the hybrid forest linear regression model has 3.71, which is also smallest. On the other hand, the prediction accuracy over there, the hybrid forest model actually achieved more than 81%, which is the highest. So it's quite similar to our Monte Carlo simulation we saw minutes ago, that the hybrid forest model produced the results with the smallest noise and mean square of errors, but also with higher prediction accuracy. So based on this, And we also can take a look at the figure 2, which is change the model efficiency when we apply the hybrid forest linear regression model algorithm over there. So we can see the change of base information criterion and BIC when we're adding more trees to the model. We can see that BIC decreasing with the increase in the trees. So the cross validated mean square errors MSE also decrease when we're adding more trees. The prediction accuracy increase when 4 trees were added to the model. So the figure and the table from comparison models pointed out that the hybrid forest linear regression model stands out either way in minimized noise and also in the forecast accuracy. Because the model involved at least 30 variables, and 2 from the continuous variables and 28 categorical variables or dummy variables over there. So I didn't propose. I didn't present the full regression results here. So I truncated 2 slides. So as we can see here, and for linear regression models, which is column 2, they're highly significant when we take a look at the linear factors. Now, if we introduce to more interaction terms of the nonlinear factors, for the linear regression model, couldn't handle so many nonlinear interaction terms, while the hybrid tree model, the hybrid forest model stands out. So this is only part of the regression results. So there are more results because we have 30 variables and also a combination of all the interaction terms. So we have quite a comprehensive model based on 4 trees from a hybrid forest linear regression methods. But in a brief summary, the one of the key variable that we're interested in will be the fundraising targets. Fundraising targets for the log transformed version will be minus 0.843. This has a significantly negative impact on the proportion of financing. So this is also understandable because if the target is higher, so target of fundraising is higher, it's hard to meet the full proportion of the financing. For the other regressors, so if the funder has supported other projects, they are significantly more likely to be supported. So typically, if the funder, the proposer, they supported other projects, which we can tell from the website, they are significantly more likely to be supportive of their own projects. The type of rewards also have positive significant influences on the proportion of financing. The products produced by or related to the project, for example, will have positive impact on the financing. And if the chance to get interviewed as reward, which also will highly likely to get financing. Now, since we also collecting data on the visualizing tools, for example, photos, so some visualization tools are significantly persuasive factors to the supporters. So, for example, if the providers provide their photos, pictures on the website, so they're more likely to win the supporters. And if slogans, logos, missions, and plans for the projects are clearly laid out on the website for the project, they're also likely to win supporters. Now, let's take a look at joining effects. The joining effects here, we typically talking about the and how the tree model and the hybrid tree model, hybrid forest model works for the linear relationships. So 1 minus SPT. SPT is whether the founders support other projects or not, so which is an indicator dummy variable. So the interaction term between this and rewards as a product have significant negative sign. So it means that when the founders have not supported other projects and the product has a reward, has a higher positive influence on supporters. RWPRD is reward with a product, and PTPROD is picture product. So both of these are dummy variables. So these interaction terms also consistently have positive sign. It means that when there are no products as rewards, and when the picture of the product becomes more important to be persuasive to supporters. Now, let's take the last one. So the last one, we also have the rewards as a product and the pictures of product and the honor certificate, which is the last one, the rewards for honor certificate. These interaction terms is also highly significant. So the meaning for that can be when there are no either products or rewards presented, no pictures of product displayed, then the pictures of products become persuasive to win financial support. So these part of the joint effects, which is significant, is that are presented here. So we have more interaction terms of the dummy variables that to be significant. However, it's hard to find the direct economic or financial meaning. So from this project, so we applied regression model to explore the factors influencing the proportion financing for crowdfunding projects. So the best model identified in our study is a hybrid forest model, which includes 21 interaction terms and only 2 linear terms. So this suggests that the relationship between the proportions of funding and the factors is often nonlinear. So the hybrid forest linear regression have a higher explanation and prediction accuracy than the linear regression model and the hybrid tree linear regression estimates. So we try to come up with a reason to explain this. So I think it's the reason that the hybrid forest model stands out is because they include more interaction terms, which they consider more nonlinear interactions, which the other which linear regression and hybrid tree models couldn't comprehensively capture this nonlinear effect. And in certain type of data, that the nonlinear relationships between the categorical variables and here are dummy variables are quite significant. So we have demonstrated that various types of rewards, including the chance to be interviewed and to receive products, are helpful for crowdfunding projects to achieve higher proportions of financing. So we also find out that the fundraising target does not have a significant impact on the size of financing. So we certainly are more interested in the interaction terms. So the interaction terms generated by the decision trees, we separate that into 2 groups. The first group we called interpretable interaction terms, which we saw in the previous slides. So, for example, the short product of original regressors with clear economical meaning, like 1 minus SPT times the whether the rewards were the product, or if no rewards were products but had pictures of products presented. So this have a direct economic meaning. However, we also have what we call sparse interaction terms. So these are the long cross products of original regressors without much economic meaning. It's hard to interpret that. So only non-zero, of course, we found that only non-zero for a small proportion of observations. Say like for 10 terms have these non-zero terms over there. So we could explain that as branches in decision trees which detect outliers. But these sparse interaction terms help us to improve the accuracy of the prediction. So our study also further confirmed the benefits of using splitting points instead of leaf nodes, because more interaction terms are interpretable. Is a short, as we can see in the tree leaves, that we have shorter paths over there. So this project certainly we're still ongoing. Right now it's ongoing. We're collecting more data. As you can tell, the data is collected before pandemic. So currently we're expanding updating the data range to verify the advantage using hybrid tree regression models and hybrid forest models. And we also, inspired by the results of this project, we also applied a hybrid tree model and hybrid forest model to some environmental economics data. For example, the willingness to pay in surveys. It also produced similar results for that a hybrid forest model stands out with higher prediction power. So, of course, that's motivated us to move further. How can we improve the hybrid forest linear regression model? So, for example, we could build regression trees with not only categorical regressors, but also include continuous regressors. We can also consider building decision trees based on a group of variables to find out more explainable joint effects, reduce the sparse effects from the nonlinear interaction terms.
So sorry, Stuart, and sorry for getting. You've got like 9 minutes left, so I don't know whether you want to get questions at the end. So
yeah. I'm sorry. So I'm done. So we also hopefully to design some algorithm with higher time efficiency, such as parallel algorithm. Yeah, this typically that's it. This is all the research we're having so far. And thank you so much for your listening. And we're looking forward to your comments and input.
It's a very interesting talk, and I'm really sorry I missed the first part. Teams would not let me in for some reason. I don't know why. So I tried to change computer, it didn't work. So anybody has got questions? So can I just start then? I know you were mentioning a lot of data points, but when you were fitting your models, so how many data points were you actually using in? I know you've mentioned a few, but I wasn't sure how much you were eventually using.
We used actually all of the 236. Yeah. So the project have 236, right? So we used all the data points of 236 in the you talk about data points, right? You're not talking about variables.
No, data points.
Yeah, data points 236 so far, because the two websites from Kickstarter and Indiegogo, actually we can see thousands of projects over there, but we narrowed the projects from the crowdfunding to social enterprising. This is our the key point. So when we search for the social enterprising, and that will reduce the projects to about 200-ish social enterprise, social entrepreneurship, and then we clean some data for after the extreme values and obvious outliers, so only add up to 236. So we're in the middle to expand it. So, but in the project, yeah, we talk about 236. Yeah.
Anybody else? Any questions? Your interaction terms, I'm guessing there is always, when you do these things, interaction terms can be spurious in the sense that, it could be some quirk in the data that's causing this and so forth. How did you sort of check that they are not really quirk of the data, but rather some clearly underlying sort of drivers of this? So.
Yeah, actually, this is the thing that concerns us most, because we don't know. This is also the thing that we try to improve in the future. So far, we found that the interaction,
Bless you.
bless you, the interaction terms. So far, we're lucky that we get the majority of them have meaning. So although they're quirky, have so many dummy variables, nonlinear terms, 0 and 1, 0 and terms in multiply together. So far, we find out most of them we can interpret that. But we do have some quirky ones that they are important for the prediction accuracy. Also reduce noise. However, it's hard to make economic meaning or financial meaning over there. So
Okay.
We are hoping in the future we could we're also looking for advice anyway. So we're hoping that in the future, if we consider, change the algorithms a little bit and consider more continuous variables, or we search, we can search for the for the variables as a group first, then expand that to the whole groups of the variables. That's called another way to reduce the possibility. Yeah.
So Jen, you've got a question?
Sorry. Yes. So it's very interesting. I mean, I agree sparsity. I'm also interested in the question of sparsity, and I like the idea of simplifying things. Do you have any generic recommendation on sparsity? I mean, from a completely different field. I was talking to somebody who saying people wanted to investigate permutations and combinations of 56 different conditions, which is huge. Do you have a point at which you say, well, there are only 2 people in this combination, we should just drop it? So separately, if you like, from the question of whether it's associated with the outcome variable, would you have a recommendation that says, don't even start to look at the outcome variable if the category is this small?
Yeah, thank you, Jen, for the question. Actually, this was a topic I discussed with Yue even yesterday. We tried to talk about the sparsity issue, and I'm thinking the way that we're experimenting this. I don't know whether it works or not. We're considering similar to what I just mentioned, that we could consider also classify the variables as group first, so that that will hopefully reduce the possibility that many non-meaningful terms pop out in the future. But I don't know whether if we group that first, what this would what's the criterion we use to group the or classify the variables first, and what criterion we're going to use. Because as you can tell, Jane, the contribution here is we twisted what Kim proposed in 2017. We twisted the model, we introduced multiple trees. So we couldn't call it a random forest model, right? Because we don't have so many variables, we only have 30. So and also it's really, that's a forest, it only means multiple trees. We just gave a name as a forest, typically just trees over there. So we're thinking we couldn't just copy paste to the random forest algorithm over there. So we have to modify that by appropriately grouping or clustering the variables in the beginning. We could, and see whether some non-meaningful ones could get screening out first.
Yeah, I think we have to. Yeah, I think we all have to keep thinking hard about that one. Thank you.
Yeah, thank you so much. Yeah.
So, if we don't have any further questions, or can I ask your application on the crowdfunding? Why did you choose to apply this method on that? Is it because the data was available, or because it was an interesting question, or?
Yeah. Actually, we applied this method to 3 or 4 different data sets. So the reason I put the crowdfunding here, I thought that would be interesting. So because the Kickstarter and Indiegogo, a bit more like a fancy modern modern things. So we also
Okay.
applied the method to meta-analysis. Meta-analysis to economic growth and pollution and environment degradation. We also analyzed the data, applied this method to survey data, whether people were changing their ideas during surveys. So we applied different methods. I thought the other two projects might be too hard to introduce within the 40 minutes. Even now, I kind of overrun my time. So yeah, that is because, yeah, I thought it might be interesting for the crowdfunding ones. Yeah.
Thank you very much. It was very, very, very interesting talk.
Yeah. Thanks. Yeah.
Thank you.